we briefly talk about the Lagrange multiplier. So Lagrange multiplier, basically, you just need to have this is we call this Lagrange function, okay? And it's the objective function minus lambda, which is the Lagrange multiplier, okay? And that's the g of xy is the constraint function. And you set the first partial derivative equals 0 to solve x, y, and lambda. And the set of solution of x, y, z, x, y, lambda here, which will maximize this capital, the uppercase f, the capital F, x, y, lambda, also will maximize or minimize this little f x and y. Basically, these two, the amazing thing is the f and so this capital Lagrange function will have maximum means suppose at this point. Okay, assume they imply this is the maximum or minimum. Okay. So it's kind of incredible result. We solved this equation last time, right? To get the maximum of the volume. Okay. That's why this one just okay. You want to maximize this function. So f of xy is equal to 100 multiplied by x to the third quarter power and y to the 1/4 of power. Okay? And we have the construction, the constraint which will be the labor and capital cannot be exceeds $50,000. So there will be for labor is $150 per unit. So it's 150 multiplied by X, and for capital is $250 per unit, and says the cannot be exceeded $50,000. As a matter of fact, this constraint should be in public constraint. However, let's say something you are able to solve. To solve this in public constraint optimization, you need to have a KTT. Use a KTT only KTT condition. The contact is to be, I think it's a contact. Oh, I forgot what T stand for. But anyway, here you can just simply assume it's equal because the when you got the maximum of X of the function that X and Y will satisfy 150X plus 250Y equal to $50. So here we need to control the Lagrangian function. Okay, so we set the Lagrangian function f, the capital F x y lambda is equal to the constraint function f of x y and minus lambda g x y. But here g x y, what's g x y? G x y will be, because you want to write this the whole equality equal to something equal to 0. So move everything to the left hand side of the equality, the equal sign. Basically, that's your G function. This will be your G function. That's G of x, y. Okay, so you are done. So it's equal to 100 x to the 175 y to 0.25. Okay, minus lambda 150 x plus 250 y minus 50,000. Okay, so we set zero equal to f of x, s of x, and 0 equal to f sub y, and 0 equal to f sub z. No, I'm sorry, sub lambda is lambda. And this would be, okay, maybe. So it should be 100 y, sorry, it should be x to the minus 1/4, and that's my sign. Okay, and y is 1/4, and minus 150. Lambda. This would be equal to 100. So it should be, I forgot this. I need to multiply, 100 need to multiply 3/4 should be 75 here. Okay. Because 100 multiply the power is 75. And here will be 100 multiply 1/4, 25 x 1/3 y to minus 3/4 minus 250 lambda. And for the last partial derivative is just equal to the constraint function. You can put the right side here, but I will also remove it. 150x plus 250y plus 50,000. Okay. Let's look at from 1 and 2, right? So and 2. I'm going to write a little bit more. Okay, let's imply I divide by both sides by 75, so move I move the 150 lambda to the other side of equality and divide by both sides by 75. So you will have actually minus 1/4, and y to the 1/4 power is equal to lambda. And this is equal to, I move this 250 lambda to the other side of equality and divide by both sides by the 25. So you will have x 3/4 y minus 3 divided by 4 equal to and lambda. And then 1 divided by 2. The equation 1 divided by equation 2, you will have 1. You will have a y over x is equal to 1/5. I can do that because the lambda is not 0 and also x is not 0. Y is not 0. So I imply x equal to 5y. Okay. And plug it back into 3. Okay, I just plug this x equal to 5y back to 3. And I can just remove myself on both sides. So what you have? You will have x equal to 5y. So be 150 multiplied by 5y plus 250y is equal to 50,000. We get let me do a little bit arrangement here. This imply 150x plus 250y equal to 50,000. Okay. So 750 and 250 will be 1,000. So they imply y is equal to 50, hence x equal to 5y equal to 50. So max f xy is equal to f of 250, 50. So equal to 100 multiplied 250 to the 3/4, 50 to 1/4 power. And this equal to 718.51. How much time? 1 more minute? Okay. So it's just the briefly go over here. Lagrange multiplier is a method to solve the constraint optimization problem. Basically, it's you need to just formulate in this problem are equal. Yes? No? We need 15 minutes of before English class. for 50 minutes unequal. How many of you think they are different? 你觉得是不一样的举手。How many of you? Everyone need to raise your hand once. 你要选，你觉得是或不是 ？How many of you think they are the same, they are equal? Raise your hand. We want people. 每个人都要举一次哦。没有的话，我就帮你记起来。再一次，觉得不一样的举手。2个、3个。How many of you think they are the same, equal? Raise your hand. Why? 你选。Why? 你举手 Why? Okay. Anyway, you can think of it. Spend some time to figure out. Okay, let's try to look at actually we worked on this problem last time. I didn't quite finish it. Okay, basically, let's try this. Let's find the area bounded by this curve on x-axis. Okay, we will find the 面积. Okay, just the bounded by this x equal y squared, or just the x-axis. We need to use the double interval to do that in this section. So we have to show some different. Okay, let's see. There are two ways. One is the dx dy. One is dy dx. For dy dx, right, we do know that also it's between 0, just this area x between 0 and 4. Okay, and 0 let's say equal to x is equal to 4. Okay, so we start with the outer interval first, dx, right? The range of x will be between 0 and 4. So that's kind of easy, between 0 and 4. But how about here? The lower limit and upper limit of the inner interval. So here it should be, because y, right, inside dy, so it would be y equal to function x, some function x to y equal to something. And let's look at here. So we fix dy, so we fix y. When you fix y, you fix y. And y will be equal to, from this point to left. So I think y here. wrong way here. When you fix y should here, dy is outside. So y is bound 0 to 2. And when I fix dy, when I fix y, and x is 1, 5. X from this to there, and that will be x equal to y squared as before. On the other hand, when x is outside, okay, so we fix x dx here. So it's from here to function just the of x, okay? So y is from 0 to here again, right? Y is equal to square root of x, because that's in the first quadrant. In the first quadrant, we only take the positive one. So usually there should be y to the square root x and y square root x. But this is not applied since y in the first quadrant of the 第一象限，所以这个就没有。So it's from 0 to square root of x. Okay, let's try again. So it depends on, I want to find the area to see of the region bounded by x equal y squared and x between 0 and 4, and also the x-axis, okay? So usually double interval could be dx dy or dy dx. For dx dy, this part basically you can think of just you just do it by adding those vertical stripes or vertical rectangles. Just get lots of rectangles vertically and add them up. So basically you fix x when you fix x, okay? You go inside, here we will fix dx, right? dx, or fix x. Or fix x. dx, I fix dx. dx, I fix dx. Fix dx, just small power x. So this area will be, but what? The height will be, you integrate from here will be this x-axis, this will be this x-axis y equals 0 啊 ，y 轴就是 y 轴 x 轴就是 y 等于0，那你就从 starting integrate from y0 to here will be y equal to square root x. And the other way is just when I fix y here. So it's starting from here to there. So we found here's what? Here's the x equal to y squared. X equal to y squared. Or x equal to y squared to here. is x equal to 4。这条线是 x equal to 4虚线。You can verify actually they are the same. How much time? 2 minutes?
1 minute.
2 more? 3 more? You can just verify the actually they are the same. But let's try to verify here. This one actually is equal to 2. This is equal to, okay, we do the integral first. The inner integral is equal to square root x. So equal to u to the whole square root x dx, and you can do it not too difficult. See, you can verify on your own. Will be 3/16, but here it's still the same. It's equal to from 0 to 2 and 4 minus y squared dy. Is also equal to 3/16. It's the same. We did this problem last time, right? This one. So I'm not going to here because you see it here. X is the outer integral, x from 0 to 2. So you fix x. Y is from here. This one is x squared minus x to x. The same. Okay, the last section.
1 minute.
The last section of the chapter 7 is the volume of solid region. Volume of solid region. Okay. We want to use the double integral to find the volume of solid region. And also, at the end, we find the average value of the function. Okay. So consider the function z equal fxy is continuous and non-negative. Okay, need to be continuous and non-negative over region R. Here R is a region, it's not the real line, it is a region. Okay. So for instance, I want to find this the piece of cake. I want to find the volume of a piece of cake. And you can think of this as the we can write in a surface z equal to fxy, and we can find a solid region. 我们要找这一个固体的